Hi everybody, this is lesson 6, the properties of limits. So far in calculus, we have looked at finding limits of functions when we're given a graph, and we've been finding limits from a table. So now we're going to find a third way, or talk about a third way, excuse me, of finding limits, which is using these properties. So if we take a look at our learning targets, it says I can use algebraic properties of limits to determine the value of a limit. So really all that means is we're going to use different algebraic properties, addition, subtraction, multiplication, division, things like that you already know, to manipulate limits in order to be able to find them. So there are times we will need to consider limits of functions symbolically. So we don't actually know what the functions are, but we're going to need to be able to manipulate the limits using these properties in order to solve these types of problems. So suppose we have two functions, f of x and g of x. The limit of f of x as x approaches a is L1. L1 is just some arbitrary y value that we don't know. We're just calling it L1. The limit of g of x as x approaches a is L2. So I do want to point out on both of these limits, we're approaching the same x value, but the y values are different. We've got two separate functions that we're looking at. But if you look here, we've got a set of 6 different properties or rules that we can use now in order to find limits. So the first one is the sum of functions rule. This says the limit as x approaches a of f of x plus g of x. So what we're doing is we are taking the two functions and adding them together and finding the limit. Well, these properties tell us that if we already have the limits, then we can actually just add them together right away. So this would simply just be L1 plus L2 because we already know the limits. Difference of functions rule. So actually this should be a minus sign. Please change that in your notes for me. Difference means subtraction. But what this one says is if we subtract the functions and find the limit as x approaches a, that's the same as already taking the limits that we have and simply subtracting them. So we can just do L1 minus L2. Product, of course, means multiplication. So the limit as x approaches a of f of x times g of x really just means take the limit as we approach a for f, which is L1, and multiply it by the limit that we get for g, which is L2. So we're really just taking the values that we have. We can do the same thing for the quotient rule. So this would end up being L1 divided by L2. And something I want to note here is we need to make sure that L2 does not equal 0 because we can't divide by 0. A constant multiple, for the constant multiple rule, we've got this number k that's just being multiplied by the function. So we can take that same constant k and just multiply by the limit that we already know. We know that the limit as x approaches a of f of x is L1. Finally, we have the nth root rule, which really just means we can take the nth root of our limit. So in this case, we're looking at f of x, that's L1. So the answer here would be the nth root of L1. Now I know that this sounds a little weird because we're not actually using any numbers here, so we are going to make sure we do some examples here to kind of show you what we're talking about. So suppose that the limit as x approaches c of f of x is 3. The limit of g of x as x approaches c is -2. And the limit of h of x as x approaches c is 4. So I want to point out once again, all three of these limits, we are approaching the same x value. X is approaching c. And if we look at these 4 examples, that's the same as well. That's really important. It has to be that same x value. Then what that means is using these properties, we can just find the answer. So let's take a look here. The first thing I'm going to do then is I'm going to take this square root and I'm going to put it on the outside because that's what this nth root rule tells me. I can put the nth root on the outside of my limit. Well, now I know that I can multiply a constant and I know that I can just subtract my two functions. So I'm going to do 3 times whatever my limit of h of x is as x approaches c. In this case, my limit for h of x is right here. So that's going to be 4. and then minus 2 times my limit of g of x as h approaches c. Well, if I look for my limit of g of x, that's going to be negative 2. And now I can just simplify this down. So it's going to be the square root of 12 minus negative 4. Well, that becomes 12 plus 4, which is the square root of 16. And so we know that this overall limit is equal to 4. Let's do number 3. We're actually going to skip number 2 for now. Let's go ahead and do number 3. So we're going to do the limit as x approaches c of 7 minus g of x squared. Well, that means then I'm going to actually break this one up. Well, no, I'm not. Sorry. I'm going to put parentheses because I know that whatever I do at the end, I'm going to have to square it because that's what's on the outside there. So I want the limit as x approaches c of 7. Well, I want to just do a quick reminder that if I have a function y equals 7, that's just a horizontal line at 7. And so regardless of the x value that I'm approaching, I know that my limit is going to be 7. And then minus the limit of g of x as x approaches c. And we did that already. That's the green one. That's that negative 2. So now I have 7 minus negative 2 is 9. 9 squared then is going to be 81. So we're really just taking these numbers that we already have and using these properties in order to find the limits. We're also going to skip number 4. I want to be able to do 2 and 4 as part of our warm-up in class. So if you want to go ahead and attempt them, you can, and then we can go over the answers together in class. If you don't, that's fine too. We're going to take a couple minutes at the beginning of the warm-up to do it. So now on the next page, we're going to be using these graphs and our knowledge of properties of limits to evaluate. So we already know how to find the limit from a graph, and we just talked about these different properties. So now we are going to find the limit that we're asked for down here. The first one says the limit as x approaches 3 from the right of f of x plus g of x. So we need to look for x equals 3, and we want to approach from the right side. So that would mean I'm looking right here. So that value is 6 plus, now I want to look at the limit of g of x as x approaches 3 from the right. So 3 from the right is going to be right here. That is going to be 8. So I know that 6 plus 8 is 14, and there's my answer. Now, it's a little different when we look at a two-sided limit. The one-sided limit is pretty straightforward because we can just do it and go. The two-sided limit, we have to be careful because we have to first look at the left and the right sides and make sure they are equal in order to get that two-sided limit. So when we look at question 2 here, and I don't know why it says loading still, I'm sorry about that, but we're just going to ignore it. So let's go ahead and look at the left-sided limit first. So we're going to do the limit as x approaches 5 from the left of 3 f of x minus 2 g of x. So if I look at my graph, I'm approaching 5 from the left side. So let's see. First, actually, I'm going to write my 3. Now I'm going to look at my graph for f of x. So as x approaches 5, well, x approaches 5 is right here. So I'm approaching from the left side. That's going to be 2. So 3 times 2. And then I'm going to have minus 2 times. Now I want the limit of g of x as x approaches 5 from the left. So 5 from the left means we're approaching here. That's a value of 4. So I get 3 times 2 is 6, minus 2 times 4, which is 8, and I get that my left-sided limit then is -2. Now let's actually look at our right-sided limit. So now we're going to do the limit as x approaches 5 from the right of 3 times f of x minus 2 times g of x. So again, I can take the 3 and multiply by my right-sided limit for 5 on f of x. So my right-sided limit is going to be 2 as well, minus 2 times the limit of g of x as x approaches 5 from the right. So that's going to be over here. We're approaching a y value of 4. And so we get 6 minus 8, and we get -2 again. Now we can see that the left limit and the right limit are equal to each other. And so we get that the overall limit then must also be -2. Now I know that that seems like a lot of work in order to be able to get the same answer, but we're going to look at another example where I'm going to show you why it's really important to do that. So I'm going to erase kind of what's going on here on the graph so that we can look at with some more colors again. So now looking at number 3, we can see that that's a two-sided limit again. So now we're going to do the limit as x approaches 3 from the right of 4 times f of x times g of x. And so again, because of the properties that we have, we know we can just take the 4 and then multiply by the limits that we get for f of x and g of x. So we want a right-sided limit as x approaches 3. So as x approaches 3 from the right side, we get 6. So we actually already did that part, right? We did that in question 1. And then 3 from the right for g of x is 8. So, oh, that's why I'm all thrown off. I'm using the same color, but I said right instead of left. Okay. Regardless, we're looking at the right-sided limits right now. And we got 6 and we got 8. Sorry about that. I messed up with the colors, but that's okay. So 4 times 6 times 8 is going to be 192. Now let's go ahead and look at our limit as x approaches 3 from the left of 4 times f of x times g of x. So again, we can take the 4 and then we can just look at our left limit and right and on both graphs. So the left of 3 for f of x means we're going to be approaching 6. Now let's look at our graph and see what happens when we approach 3 from the left side on g of x. That's going to be down here, which is going to be 1. So I get 4 times 6 times 1, which is 24. And now I can see that this one, the limit does not exist. So I'm actually going to write it all down here. I'm going to say the limit as x approaches 3 of 4 of f of x times g of x does not exist because the limit as x approaches 3 from the left of 4 times f of x times g of x does not equal the limit as x approaches 3 from the right of 4 times f of x times g of x. So unfortunately, we do have to write that whole thing as part of our justification there. So you'll want to make sure that you include that. We're going to go ahead and leave number 4 to be part of our warm-up as well. I know that this was kind of a lot in here, and it seems a lot more confusing, I think, than it actually is. So hopefully once we do some practice, you guys will feel that way as well. If you had any questions, please make sure you wrote them down. And I usually tell you guys which page numbers we're on, so sorry about that. This is pages 27 and 28 of your packet. I should have told you that ahead of time. Hopefully you figured that out already and you were able to take your notes. Thanks for watching, guys.